And I'm going to bring our next speaker, who I just adore and think is awesome. This is Andy from Fairwinds, also my company. But he's one of the best people I've ever worked with. So Andy is here.
Yes.
Andy is here to talk to us about, all of this demos, all of what we've been going through, but like, how do you actually provide Kubernetes best practices at scale?
Andy is another KubeCrash vet. Andy suffered through us when the Hopin platform couldn't handle large demos, and we like troubleshooted things on on the fly. Troubleshoot? Okay. So yes, thank you, Andy, for coming back again. And I think we've got some of our technical difficulties, figured out, but not all of them apparently.
All right.
All live events are subject to technical diffdifficulties. It's fine.
That's awesome. Great. All right. Thanks, Andy. We will take it back to you.
All right. Thanks for having me. For those who don't know me, I'm the CTO at Fairwinds. I am the author of a few different open source projects and maintainer, particularly Goldilocks and Pluto, a couple of my favorite projects. But I'm not here to talk about those today. We're here talking about multi-cluster, and we're talking about lots of different strategies for that. I know we've seen a lot of great demos and seen a lot of good things about running applications across multiple clusters. And I want to talk a little bit about consistency and how we run a lot of clusters in more consistent ways and in more compliant ways in some cases. How do these slides work? There we go. I already introduced myself. I work for Fairwinds. We do Kubernetes all the time. I'm not going to read you our little mission statement here, but just be aware of who we are. So let's talk about what I mean when I say inconsistency. So inconsistency happens when we build clusters in lots of different ways, and we don't have any controls around how we deploy to them. Kubernetes is a wonderfully flexible system. It's a very complex system. It lets us do just about anything we want to do. And so if we don't restrict how we're doing those things, then what we end up with is something along the lines of this, where we came into it with good intentions, and we probably find all of these things very useful, but we have no idea how to find different things. We don't have any sort of guardrails around how things get into our system. We don't have any guardrails maybe around how we've set up our system. So like if we're not using infrastructure as code, maybe we have 10 different clusters and they're all built differently, or we have, say, 10 different clusters, they're built the same, but everybody's deploying to them in a slightly different way. And what this does at a small scale, it's not such a big problem, right? On a small scale, we can handle it. We can wrap our heads around all of that complexity. But when you start getting to, 5, 6, 10, 20, 200 clusters, what you start to see is what we have in this picture. It becomes kind of a mess. And so we need consistency. And you might say to me, Andy, we don't need consistency. It's fine. Like everybody running in the system is smart. They know what they're doing. It's not a problem. And I think what we really need to address before we talk about how to be consistent is what's the cost of inconsistency? Why is this bad, and what does it do? How does it negatively impact, me as an operations engineer, or even how does it impact my business? Does it really matter? And I'm going to quote Danielle here, and she wrote a great article about the cost of auditing and maintaining Kubernetes infrastructure. And so if a team spends 10 engineering audit days, so if they just spend 10 days to look at what might be, wrong with their Kubernetes cluster, or what policies they need to implement, or, try to fix things in their clusters, they're going to spend $69,000. That's like half of the average SRE salary, I think, every year to just audit. That's just auditing. That's just finding where the problems are. And so, we may have spent $69,000 to find all of our problems, and now we have a spreadsheet that lists all of these problems. That doesn't even get into the cost of mitigating issues across our environment. So first of all, it just costs time, and time is hard to evaluate as far as cost, but it is expensive, especially when you start to scale up into many, many clusters. The next thing that inconsistency can cost us is outages. So if any of you are Reddit users, I know we were just talking about Reddit a few seconds ago. You may have been familiar with the Pi Day outage earlier this year. It was in March of this year. And Reddit was down for, I think, half a day, a whole day. It was a very large outage. Reddit is very well known for running a lot of Kubernetes clusters. And they are also really great at putting out outage reports explaining what happened. And if you look through that outage report, one of the things that you'll see is that they accumulated a set of bespoke clusters, like I was talking about earlier. They had no guidelines or controls around how their clusters were built or how they were deploying to them. And that led to an inconsistent upgrade cadence and inconsistent configuration between clusters, and it ended up costing them a massive outage. And obviously this is at a large scale. It accumulates over time. But I guess the argument I'm trying to make here is that we have to be consistent up front. We have to build with consistency in mind. We have to put in guardrails up front in order to mitigate these potential issues. It might cost us more in the short term while we're building all of this infrastructure, because it does take more time to build consistently. But the potential risk that we're mitigating is huge here. And so I've put together this slide. You may think, okay, well, that's, just impacts, one little part of the business or something like that. And I don't think that's true. I think inconsistency eventually impacts everyone within a company: the developers, the end users, the platform, the DevOps folks, the security and compliance teams, and the business itself in lots of different ways. And so we can't afford to keep building infrastructure without putting guardrails in place up front. So now, what do we do about that, right? Like, we can talk around this all day. I could say, you have to build consistently. You have to build consistently. But how do we actually do that? What's the process by which we go about doing that? And I think that we have a lot of different tools available to us to do this. And the one I'm going to talk about today is our open source Polaris that can enable this, but there's, lots of different tools. The concept is really picking your set of policies that you want to enforce or that you need to enforce, right? Start small. Start with your basic security best practices, setting resource requests, maybe, not running containers as root, or you have to use our Helm chart template in order to build your service that has a lot of these best practices built in, or whatever that is. Start small, choose the things that you're going to do, then figure out where your exceptions are, because you're going to have them, right? Anytime you introduce a policy, there are things that need to have an exception. Your CNI is going to need a lot more privileges than your average application container running. Your control plane may need to be exempted from policy, or maybe your control plane is managed by somebody else and you don't have to worry about it. But develop those exceptions by testing in different environments. Make sure that your policies are in place, and then enforce the policies at admission time. And this is the most important step. If we start enforcing these policies before anything gets deployed into our cluster, we're going to avoid that inconsistency up front. We're going to only ever deploy in the manner that adheres to our policies, and we'll end up with a much more consistent environment down the road. That environment is more auditable. It is probably easier to maintain compliance in that environment. It's going to look, if you run the exact same policies across all of your clusters, you're going to, enforce that consistency up front. So then, enforce those policies, install your cluster infrastructure, keep going. As you add more policies, go back through this process. Implement a policy, develop the exceptions list, enforce the policy at admission time, and then just keep moving on. And so if you can get into this pattern of always having these policies in place, you'll be in a much better state going forward. So let's talk about this in regards to the demo application that we have. So we've seen today Flynn and others did a wonderful job of putting together this multi-cluster environment with lots and lots of cool networking and ingress and an app and all of that stuff. So what I did was I stood that environment up, and I stood the clusters up just by themselves, and I installed our tool Polaris. And right off the bat, I had to write some exceptions. So I created some exceptions for control plane components and things like that. But what I did was I got this baseline environment to this state right here. And we see here we have no failing checks whatsoever. All of our checks are passing. We only have 7 controllers in the cluster. We only have 6 namespaces. And so we're in a very small state. We haven't deployed anything to the cluster. Then, just to sort of prove the point of, how we can create more work for ourselves going forward without doing it up front, I went ahead and I installed Linkerd. Well, as soon as I installed Linkerd, we added 137 warnings across our cluster. Most of them are efficiency and reliability related, but there are a few security related ones that are probably necessary exceptions that we need to add because Linkerd does need certain levels of permissions in the cluster. But this is our opportunity to take these warnings, either fix them or go add exceptions for them and get ourselves back to this state before we deploy Linkerd to any more clusters. Now we have a set of policies that works with Linkerd, and we can safely deploy those policies across all of our clusters and start enforcing them at admission time. I did the same thing with Cockroach, much smaller footprint. So this is on top of what we had for Linkerd. Of course, the dog starts barking in the middle of my talk. But anyway, Cockroach added a few more warnings. And then we added Emissary, and we keep going up. And we added the world application, and we keep going up again. So at this point, all we have is basic infrastructure, right? We've just added, I accidentally hit the button. We just added basic infrastructure. And we have 271 things that we need to address in our cluster. If we had just taken the time to address them as we were installing these things, we wouldn't have 271 warnings. We'd have 0. Then we would have a very consistent environment across all of our clusters where we're meeting all of our policies. We can audit those policies, and we can, keep deploying apps in a consistent way across our clusters. So the argument I'm making today, if it's not clear, get those policies in up front, start enforcing them, and bring the pain forward. A former coworker of mine liked to quote the continuous delivery book, and I think this is a great example of this situation. We need to bring all that difficulty forward, because if it's going to be more difficult down the road, then slowing ourselves down slightly up front is going to make it 10 times easier down the road. So I have a brief demo, and I'm going to keep this short. I know I've been really quick, but I'm going to keep this short today so we can get everybody back on track. Feel free to shoot questions at me in the chat over here. And is my screen share working? It seems to have maybe quit. Oh, it is working. It's just the preview didn't work. All right. So what I've gone ahead and done, I showed you the Polaris dashboard already, the screenshots from that. I have the clusters here running in my local environment. I believe Flynn noted earlier that running all of these K3D clusters can eat up a laptop, and it definitely is the case. I had to go give more resources to Docker to make this work. But I haven't installed any of the application in this. All I've done is install Polaris. So if you go to the repo and you go to the Polaris directory, there is a setup Polaris script that will install Polaris with mostly a default values file with all of these different policies. What I've done here for the screenshots I took earlier, I had Polaris in warning mode only, and that's why everything showed up as warnings. I've gone ahead and put a few different things that I think are important into danger mode or danger severity. So memory requests missing, CPU requests missing, cluster role bindings to the cluster admin role, privilege escalation, and things like that. And so I've gone ahead and put them into breaking mode or blocking mode. And if we look at actually, if we go back to that values file, sorry, we have the webhook enabled and in validating mode. And I've gone ahead and installed it. I've also installed Cert Manager in order to manage the certificates for the admission controllers. So if you use admission controllers and you don't want to deal with certs, Cert Manager is great for that. Little shout out to the previous talk. And what I'm going to do is I'm just going to go ahead and run through the install. And what we'll see, if I don't know if anybody's actually gone through the full install yet today, but if we already ran create clusters, and then I think if we look at our README, the next step is set up Linkerd. So I'm going to close this. I'm going to set up Linkerd. And what we're actually going to see is, hopefully, there we go, right here, we're not even going to let this in the cluster now because we said, you really have to set CPU and memory requests. You don't have to set up, you don't have to set limits. I know there's some controversy around CPU limits and all of that. That's fine. But CPU and memory requests are an absolute must-have in this cluster. So we're going to block containerd or Linkerd based on that. And that's the majority of the issues here with Linkerd. But now I've just forced anybody deploying into this cluster to go back and deploy better, right? And it's going to make a more reliable, more efficient, more auditable, more compliant cluster. We can obviously roll these policies out via infrastructure as code to all of our clusters so they all look the same. And then, for the things that need it, we have the exceptions. So, for example, in order to get to 0 issues, I had to exempt some things, KubeAPI server, core DNS, the local path provisioner that comes with K3D from certain checks because they need those permissions. But now we actually have an audited list of, hey, these are the places where we're violating our policy, and here's why. If we have a pull request to that, we can say, this is why we audited why we changed our policy for this particular thing. So there's lots more we can do with Polaris. Of course, there's a dashboard we can look at. I showed the screenshots from that earlier. And then, quick plug, if you want to run this across, many, many clusters with a lot of other tools mixed in as well. If you want to add Goldilocks or Pluto, we do have a free tier of our enterprise platform that allows you to do this at scale with a single UI and see all the clusters in one place. And I think that is everything I have.
Yes, absolutely.
That's awesome, Andy. Oh, you'd heard me.
I was thinking you're finishing so early. Or maybe not. We just had a little situation here. But it's all good. So did we have any more questions for Andy, or have you pretty much tackled them all?
We haven't had any questions, but as we've done all day, if you do have questions, please, Andy will stick around for a bit and answer any of those questions.
Looks like you're getting some support. Johannes, thank you for being here for so many of the presentations and for being active on the chat. Looks very cool.
So with that, Andy, I'm gonna kick you out. Great presentation.
Right.
Thank you so much.
Thanks, everybody. Have a good one.
I have booting people out.
Yeah.